हेलो।
हेलो विजय,
हाँ,
तुझे को बोलना है।
कहाँ बोल रही हो? सबके लिए? अच्छा, ठीक। ठीक है, ओके। ओके, ठीक है। ओके। अंजब, मेरा लेक्चर चल रहा है, सोमू लेक्चर के लिए गया है। मैं का फ़ोन यूज़ कर रहा हूँ, बाद में फ़ोन कर रहा हूँ, ठीक है। हाँ, ना मैसेज करने का पहले। चलो ठीक। अरे सर, भूल गए क्या लिंक अपलोड करना? यार हद हो गई यार। 15 मिनट लिंक अपलोड करने में जाता है यार। नहीं रखना लेक्चर तो कैंसिल करो, ऑफिस के इतना झमेला है। Hey guys, good evening. Can you see my hand? So, okay. So today in our lecture we'll be only doing a revision of what of the chapter group 1 and 2 elements. So it's more of I being speaking and you only listening. So to make it less boring, I'll be using this same video जो मैंने आपको ये पढ़ाया था। So it's more of a one short lecture today, and majority of the part is covered. So we were doing this group 1 and group 2 elements. If you see, they are found in the extreme left of the periodic table. They are known as S block elements. Why? Because their outer or valence electrons enter the S orbital. Okay. And maximum of 2 electrons can be accommodated. Group 1 may NS1, group 2 may NS2. Rishikesh, good evening, and I hope I could convert that class into a real one. Lithium, sodium, potassium, rubidium, cesium, francium. Hydrogen is not a part of the alkali metals for various reasons we had discussed. Right? Now, when we talk about group 1 metals, lithium is the most abundant of all these metals of group 1. अरे भाई सीधा रहे. Francium is radioactive. Okay. क्यों autofocus हो रहा है? Why is it testing my patience? Now, the name alkali metals, why? Because once you put it in water, they produce hydroxides, and which are obviously soluble alkalis, and that is why they are called as alkali metals. We had discussed this, and if you test it, it will turn the phenolphthalein as pink, which proves that they are highly basic in nature. Let us look at the electronic configuration. If we talk about their general electronic configuration, will you stop auto-focusing? ठीक है. अरे भाई मैं गरीब हूँ स्वयं, मेरा कुछ वो फोकस का फीचर नहीं है. This is the general configuration which we have of these elements. If you look at their electronic configuration, all of them are ending in NS1, and NS1 is their general outer shell electronic configuration. Okay, so that's why we will, N is the last energy level, and S obviously the sub energy level, and 1 the electron in them, and that's why they're in the group 1 of the periodic table, right? So because of the similar configuration, alkali metals have obviously similar chemical and physical properties, which the trends we will discuss and see, and we have already seen. They're very reactive. They're not found in their pure state because तुरंत react कर जाता है. They have to be stored under oil because air or water के साथ they quickly react and they are not stable. They are shiny, soft, silvery metals. Soft cut metals can be cut with knife. Good conductors, obviously, because they are metals, and they form oxide on the outer surface. Why? Because they readily react with oxygen. Simple as that. I am very sure that we have discussed each and every point over here. Just to make it a little more non-boring, I'm using the video again. We have discussed all these points. So this is what we're talking about. Simple. It can be cut with knife, oxide layer, blah blah blah. So many things. Okay. Now this single valence electron can easily be removed because it is loosely attracted with the nucleus. Okay. This is lost, and the resultant electronic configuration becomes that of the noble gas. इसका preceding noble gas का जो configuration होता है वही हो जाता है. Okay, so they form cations with a charge of +1. They form cations with a charge of +1 because they easily lose that one electron. Sir, आप दिख जाते हो तो बोर ही नहीं होता. Well, that's very humble and nice of you, beta. But I am a bit exhausted, so I chose this. Let us look at the periodic trends and the properties. We had discussed this on the board. If we look at the atomic size down the group, the atomic size is increasing. Reason because the number of shells down the group is increasing, and that is a reason why the atomic size is increasing. Simple as that. अच्छा ये देखो आयंस की अगर बात करूं तो इट्स गोइंग टू बी लेस ऑफ द साइज of the corresponding atom. It's going to be smaller than the corresponding atom because it loses electron. बेटा वो electron lose करता है तो वो contract होता है, but it is very similar to atomic size. It also decreases down the group. But if I talk about across the period, the atomic size decreases. That is why alkali metals are the biggest atoms in across the period, and down the group obviously नीचे वाला atoms बड़ा होता है. That way. Largest atomic radii कहाँ देखने को मिलेगा? Obviously cesium, francium, because down the group this increases. तो सबसे ज़्यादा किसका होगा? Obviously इसका होगा. Ionization potential is the amount of energy required to remove the most loosely bonded electron in the outermost shell. Since this is loosely bonded and there is shielding effect, less amount of energy is required. ठीक है, तो in general if I talk, ionization potential down the period decreases in group 1 elements. Francesium being an exception, of course, it's a radioactive element. Okay. Lithium, sodium, and all. The enthalpy of solvation or hydration, enthalpy simply means amount of energy released or absorbed when that element gets associated with water molecules or when it is dissolved in large amount of water molecules. Now, जैसे जैसे आयनिक साइज बढ़ता है हाइड्रेशन एंथैल्पी भी कम होता है. इट इजीली बिकम सोल्यूबल इन वाटर. So these ions, as the size increases, they become easily soluble in water. So they tend to form more hydrates, better hydrates, or they surround with more water molecules as we move downwards. That way. How can we test for the presence of alkali metal in a compound? कि किसी कंपाउंड में alkali metal है, सिंपली फ्लेम टेस्ट करने का, वो कंपाउंड को लेने का और उसको फ्लेम में बर्न करने का. Electrons will get excited and because of the heat of the flame and they will go to the excited state because electron को निकालना बहुत easy होता है in alkali metals. Now once these electrons get excited, they will obviously excite and they will come back and fall to the ground state. Same is going to happen. Now once they are falling to the ground state, they are going to release some energy. This energy, because of this released energy, the color of the flame changes. ठीक है, तो ये ब्लू कलर का फ्लेम दिखता है, which is characteristic of sodium. तो हर एक एलिमेंट एक अलग कलर दिखाता है. मैंने ब्लू बोला, हम येलो बोलेंगे अब. The energy released, ना बेटा, the energy released during the flame test. Energy is in the visible spectrum. ये देखो, एक एप्लीकेशन बेस्ड क्वेश्चन ये हमने देखा था कि एक बंदे का ना एक फैक्ट्री में एक्सप्लोजन हुआ, तो वो बंदे ने क्लेम किया कि भाई फैक्ट्री की वजह से मैं अपाहिज हो गया। तो इज द एम्प्लॉय बीइंग ट्रूथफुल बिकॉज ऑफ द प्रेजेंस ऑफ पोटेशियम वी गेट अ लिलियक फ्रेम। और पोटेशियम हाइड्रोक्साइड का वो ये था, क्या बोलते, फैक्ट्री था। तो वो कलर तो ग्रीन कलर का था, वो पोटेशियम लिलियक कलर देता है, तो एम्प्लॉय का क्लेम पास नहीं हुआ। If we talk about the chemical properties, I hope you understood that, huh? वो एम्प्लॉय बोला कि फ्लेम का कितना कलर्स होता है, इट डिपेंड्स कि भाई कौन सा एनर्जी रिलीज हुआ है इलेक्ट्रॉन ड्रॉप होते वक्त। तो कहीं ब्लू, कहीं ग्रीन, कहीं रेड, कहीं लिलियक, कहीं पर्पल, ब्ला ब्ला ब्ला, ऐसे कलर्स अगर देखा जाएगा तो बेसिकली 7 ही होता है, बिकॉज विजिबल स्पेक्ट्रम में 7 होता है बेटा विपक्योर। एम्प्लॉय इज अ केरन, यस आई गेट योर फीलिंग्स स्वयं। वो ये था पंचायती एंड कलेशी। तो जबरदस्ती कंपनी के ऊपर क्लेम डालना चाह रहा था। कंपनी बोली कि भाई अगर पोटेशियम केमिकल बर्न हुआ होता तो पर्पल कलर का फ्लेम आता, बट जब ब्लास्ट हुआ तो इट वाज अ ग्रीन कलर फ्लेम। तो इट इज नॉट बिकॉज ऑफ द केमिकल ऑफ द company, but it is because of some other problem. So you will not get the paisa. You are bad. You did this. That. अच्छा, they react with oxygen. They react with oxygen readily. They react with oxygen to form corresponding oxides. So ये ऑक्साइड्स, मोनोऑक्साइड्स, पेरोक्साइड्स एंड सुपर ऑक्साइड्स बनाते हैं। फॉर एग्जाम्पल लिथियम इज फॉर्मिंग लिथियम ऑक्साइड, सोडियम इज फॉर्मिंग पेरोक्साइड, एंड sodium and other potassium and other metals are forming superoxides. Now, if I talk about their oxides, silvery whitish color के solids मिलते हैं, crystals मिलते हैं इनके। ये देखो, these oxides when dissolved in water they form corresponding hydroxides, and these hydroxides are alkalis. So this is one of the reasons why they are calling them as alkali metals. ओके, तो पोटेशियम सुपर ऑक्साइड, सीजियम सुपर ऑक्साइड के कलर्स की अगर मैं बात करूं तो पोटेशियम सफेद है, सीजियम अपना येलो है। Oxidation number, I do not want to get into this because this is a separate chapter which will be taught to you. So how to find out oxidation number and all, that is a different set of topic altogether. Okay. Lithium in normal oxide oxygen will have -2. In peroxide oxygen will have -1 oxidation state, and in superoxide oxidation state of oxygen will be -half. You do not have to bother about this over here because this is a separate chapter where we will be taught about how to assign oxidation number and find oxidation number. Different thing altogether. पूरा chapter अलग है वो, ठीक है। So, for the element to be called for the compound to be called a superoxide, oxygen का oxidation state has to be -half. Okay. Now, group 1 elements readily react with water to give hydroxide and release hydrogen. मैंने in depth आपको ये reactions पढ़ाए हैं कि कैसे Na+ बनता है, H+ OH- बनता है, how they combine, how hydrogen is formed on the board. I have taught you all these reactions. Okay, then lithium on reacting with hydrogen form lithium hydrides, sodium, potassium and other elements. With hydrogen they form their corresponding hydrides. बहुत simple reactions हैं because they simply lose one electron and form ionic bonds with the compounds. With halogens they form corresponding salts and they vigorously react because इसको एक इलेक्ट्रॉन देना है, उसको एक इलेक्ट्रॉन लेना है. Highly exothermic reactions and form the corresponding metallic salts. Obviously, they are crystalline solids, high melting point, soluble in water. The salts of group 1, large negative enthalpies of formation means they are very stable compounds. उनको तोड़ना becomes a bit difficult. So that is why they have high melting points and all. Crystalline है इसलिए soluble in water भी है. This is about the salts of group 1. Now, they have a great tendency to lose electron, and halogens have a great tendency to accept electron. So since they are losing electron, they are getting oxidized. बट दूसरे के अंदर ये इलेक्ट्रॉन ऐड कर रहा है तो दूसरा क्या हो रहा है, रिडक्शन, रिड्यूस. तो ये क्या हो गया, रिड्यूसिंग एजेंट. इसकी वजह से इसका रिडक्शन हुआ तो ये क्या हो गया, रिड्यूसिंग एजेंट. So they are good reducing agents. Who? Alkali metals. Okay, they readily dissolve in liquid ammonia and they form electronated ammonia. ये मैंने बोर्ड पे आपको अच्छे से समझाया था. And this blue color of the solution is because of the electronated ammonia. These solutions are paramagnetic because they have unpaired electrons. They are weakly magnetic. ये भी मैंने आपको समझाया था, diamagnetic and paramagnetic. But once kept for a longer time, this hydrogen gas will be released and it turns to diamagnetic. Okay. They convert into bronze color and they become diamagnetic. बच्चों, please confirm I have taught this in on the board. Then we also did the different uses of alkali metals. Lithium is used to make engine parts. Okay, many lithium alloys are used in constructions and क्या बोलते हैं, other machine parts, and to construct various type of batteries, lithium ion batteries and so on. Right? Liquid sodium is used as a coolant in nuclear reactors. Coolant मतलब जो excess energy release होती है उसको ठंडा करने के लिए. Then in automobile fuel first lead was used and it caused a lot of pollution. बहुत pollution होता था तो उसके लिए we replaced क्या बोलते हैं, lithiums and sodiums. Then potassium, murate of potash is used in the preservation of vegetables. It is used in the production of soaps and so on. Okay. And cesium is used in the manufacture of solar panels. It is फ्रांसीसियम तो भाई रेडियो एक्टिव होता है तो उसे रहने दो, उसको साइड में रखेगा सुनील. Okay, now we discussed about the anomalous behavior of lithium, which is the diagonal relationship with magnesium because of its similar size, similar ionic radius or charge to radius ratio जो भी हम बोले उसको. Because of its similar size, its similar ionic radius, lithium has a smaller radius as compared to other group 1 elements. So it will have a higher ionization potential obviously. Okay, it is atypical. बाकी सब सिल्वरी वाइट होते हैं. ये देखो डार्क ग्रेइश, डेंसर और हार्डर होता है. छोटा एलिमेंट है इसलिए डेंसली प्लेस्ड होता है. That way. Least reactive, of course, because high IP. If we look at this table of क्या बोलते हैं, it is a very poor, very less tendency to oxidize. So it is at the top of the radioactive series. not radioactive series, sorry, simply activity series. Lithium chloride, it is the only chloride which forms a dihydrate. बाकी कोई भी compound, it does not associate itself with water. They are anhydrous. They are dry salts. Okay, the exception to the other alkali metals because of its size and high IP values. Then now lithium is forming this lithium is not reacting with organic compounds, others are reacting in a different way. Lithium nitrate बनता है, ठीक है. Other elements they do form nitrates and nitrites when reacted. Lithium does not break. It generally forms lithium oxide. It forms lithium oxide, nitrogen dioxide, and oxygen gas is released. So lithium nitrite is behaving differently as compared to other elements. यहाँ देखो, sodium nitrite is breaking into sodium nitrate and oxygen. So that is the difference. Then lithium fluoride को लूँ और sodium fluoride को लूँ. So, for the same amount of salt of the metal, ठीक है, जहां मैं 4 ग्राम सोडियम फ्लोराइड को पानी में डिसॉल्व कर सकता हूं, वहां पे मैं सिर्फ 0.13 ग्राम ऑफ लिथियम फ्लोराइड को डिसॉल्व कर सकता हूं. Because its shape is different, because its enthalpy is different, hydration enthalpy. Lithium and magnesium have a lot of similarities in their chemical properties. One is forming nitrates, ठीक है. ये बाकी के elements, group 1 elements, they do not react with nitrogen to form nitrates, but lithium does. They both react slowly with water. Other elements of group 1 they react very quickly. दोनों में से कोई भी सुपर ऑक्साइड्स नहीं बनाता है. These are the similar properties of lithium and magnesium. You can take a screenshot, beta. ये it's a very nice and consolidated form. Then both the carbonates they decompose on heating to form carbon dioxide and the oxides, and their chlorides are hydrates and soluble in water, which जो बाकी के group 1 elements नहीं दिखाते, group 2 के दिखाते हैं. तो lithium is showing its properties similar, very similar to magnesium. इसका you can take screenshot or make notes because this is important. And क्या बोलते, you can use it in making your answers. book में भी इतने अच्छे से नहीं दिया है. तो if they ask you how is lithium and magnesium similar in properties, जो आपके सामने है, अगर आपने इतना लिख दिया, परफेक्ट आंसर माना जाएगा. Okay, I hope you all have taken the screenshot or written it down. Tell me whatever you are doing, so accordingly I will proceed ahead. I don't think so there are much students today, so I think I can go ahead. Just a one shot lecture, that's why I'm not stressing on points, it's just a revision. लिख लिया? Jitesh and others. Took screenshot. That's okay. I'm absolutely okay with the screenshot, but do make a note of it after you note it down in the book because this will help you with it. You may proceed. Okay, I will proceed. Jitesh Kushwaha. if we talk about the important compounds of group 1 elements, again not in the portion but ठीक है मैंने पढ़ाया था तो रिवाइज कर लेते हैं. ठीक है, सोडियम कार्बोनेट which is commonly known as washing soda. Let us not go through this because अभी recently last lecture में ही हमने ये वाला वीडियो देखा था. Let us discuss about group 2 elements का properties first. I do not want you to watch the same video again and get bored. We know the biological importance, हमने ये सब किया था, इतना डिटेल में नहीं करना है. Yeah, over here. So proceed with a naughty face. Okay. ग्रुप 2 के एलिमेंट्स की अगर हम बात करें तो बेरिलियम, मैग्नीशियम, कैल्शियम, स्ट्रोंशियम, बेरियम एंड रेडियम. स्ट्रोंशियम, बेरियम, रेडियम, they are the group 2 of the periodic table. ठीक है, all of these elements they have 2 electrons in the outermost shell and NS2 is their general outer shell electronic configuration. Again, beryllium is as an exception, and all others are called as alkaline earth metals because they are oxides and hydroxides are found in nature and they are alkaline in form. So ठीक है, most abundant elements की अगर मैं बात करूं तो calcium and magnesium which are found on planet Earth, they are the 5th and 6th most abundant elements on planet Earth by mass. बाकी सब elements are also present but very rare, and radium तो radioactive है तो उससे दूरी रहो. That way. Now, if I talk about their electronic configurations, बच्चों, their general outer electronic configuration is going to end in NS2. पहले वाले का 2s2, दूसरे वाले का 3s2 and so on. If you see, this is the detailed electronic configuration of elements. So सब में common is s2. So 2 electrons in the outermost shell. Obviously easy for them to lose those 2 electrons and form plus 2 ions, and N is the highest occupied energy level. So this is how you can generalize their electronic configuration or write a short form of their electronic configuration. Okay. So they form cation. अगर इसके 2 इलेक्ट्रॉन निकाल दिया तो they will form a cation of the configuration of the nearest noble gas. Simple as that. है ना, 2 इलेक्ट्रॉन निकल जाएंगे. अब एटॉमिक साइज की अगर बात करें तो अक्रॉस द पीरियड एटॉमिक साइज कम हो रहा है एंड डाउन द ग्रुप बढ़ रहा है. तो एज कंपेयर टू ग्रुप 1 एलिमेंट्स इनका साइज थोड़ा छोटा रहेगा, बट डाउन द ग्रुप देयर साइज इज गोइंग टू इंक्रीज. सो एज वी मूव डाउनवर्ड्स द साइज इंक्रीजेस with ionization potential. If I talk about that, decreases because the size is increasing down the group as we move down the group this way. So group 2 elements are smaller than group 1 elements but bigger than the other elements in the periodic table. So if you want to have a view of the trend of the atomic size of group 1 and 2 elements, this is how it will look like. ऐसे कुछ दिखेगा, sizes of the elements. A beautiful view. You can take a picture and take a printout and keep it in your room to understand the atomic sizes. Do not have to by heart any values, not needed at any point of time. Right. So again, the ionic size is very similar to the atomic size. भाई इस कटायन बनाता है तो कटायन बनाएगा तो साइज श्रिंक होगा. Again, down the group, the adic size will increase because the atomic size increased tha that way. This way. But IP is greater than group 1 elements, but obviously is less as compared to the other elements in the period. So पहला एक इलेक्ट्रॉन निकलता है, that is your first ionization energy to remove the one electron. फिर एक और इलेक्ट्रॉन निकालने के लिए मुझे एनर्जी देना पड़ता है which is your second ionization energy. So दोनों को ऐड किया, फर्स्ट आयनाइजेशन सेकेंड आयनाइजेशन, तो इट्स गोइंग टू बी हायर. Second ionization energy will be the energy required to remove the second electron over here. Second ionization energies are higher as compared to first. एविडा रीजन बीइंग एक इलेक्ट्रॉन ऑलरेडी निकल चुका है एंड न्यूक्लियर चार्ज स्ट्रॉन्ग हो चुका है. सो द न्यूक्लियस इज अट्रैक्टिंग द लास्ट इलेक्ट्रॉन मोर स्ट्रॉन्गली. So to remove that second electron, I will require more energy in this case. So obviously यहाँ पे ज़्यादा आईपी लगेगा एज कंपेयर टू अल्कली मेटल्स. ग्रुप 2 के एलिमेंट्स को ज़्यादा ही लगेगा. बट सेकेंड आईपी की बात करूंगा तो अल्कली मेटल्स की हायर रहेगी एज कंपेयर टू अल्कलाइन अर्थ मेटल बिकॉज ऑलरेडी नोबल गैस कॉन्फ़िगरेशन अचीव हो गया है एंड ग्रुप 2 अचीव होना बाकी है. सो फर्स्ट वन किसका ग्रेटर होगा? अल्कलाइन अर्थ मेटल्स का, अल्कली मेटल्स का काम होगा. एंड सेकेंड अल्कलाइन अर्थ मेटल्स का काम होगा एंड अल्कली मेटल्स का ज़्यादा होगा बिकॉज दे हैव ऑलरेडी बिकम स्टेबल. They do not want to lose any electron further. Simple as that. किसी एक घड़ी में टाइम नहीं मिल रहा है. I have to make this. Okay, cool. ठीक है. Now, if I talk about their solubility or their hydration enthalpy, the amount of energy released, when iron is dissolved in a large quantity of water, again that is decreasing down the group, but it is better as compared to alkali metals. So they form hydrated salts, obviously. तो group 2 have larger hydration enthalpies as compared to group 1 metals. Okay, they are found as extensively hydrated salts. ये देखो water associated salts रहेंगे but group 1 में नहीं होता है. 6 water molecules associated. So, sodium or potassium, they only form hydrates, they do not form hydrates at all that way. Now if I talk about their physical properties, again same physical properties, silvery white, shiny, soft metals but harder as compared to group 1 metals, good conductors of heat and electricity because they are metals. This is how these metals look like. Beryllium देखो, magnesium, calcium, strontium, barium. They have higher boiling points as compared to other. एक minute, hold on. High melting points and boiling points. It might be a little boring, but please keep up with me. Okay. Group 2 metals in the any compound or salt, ये आप लेबोरेटरी में करोगे. सेम रीजन, इलेक्ट्रॉन्स गेट एक्साइटेड एंड देन दे फॉल बैक टू देयर ग्राउंड स्टेट. While falling back, they release energy in the visible spectrum, and this is the reason why we see different characteristic colors for different elements depending on what amount of energy or wavelength they are releasing that way. Okay, so colors, if you want, you can remember for क्या बोलते हैं एंट्रेंस स्ट्रॉन्शियम से पटाखे बनाते हैं जो दिवाली में ऊपर जाके फुटते हैं. अभी मैग्नीशियम एंड बेरिलियम दे डू नॉट गिव फ्लेम टेस्ट बिकॉज द इलेक्ट्रॉन्स आर वेरी टाइटली हेल्ड एंड दे डू नॉट रिलीज. वो निकलते ही नहीं है अपने शेल में से, तो निकलते नहीं तो गिरेंगे नहीं, गिरेंगे नहीं तो एनर्जी रिलीज नहीं करेंगे, एनर्जी रिलीज नहीं करेंगे तो फ्लेम टेस्ट नहीं देंगे, कलर चेंज नहीं करेंगे फ्लेम का, तो वी विल नॉट बी एबल टू सी अ कैरेक्टरिस्टिक कलर ऑफ देम ओवर देयर. If I talk about chemical properties, same with oxygen, water, they form oxides, hydroxides, halides, carbonates, sulfates, nitrites. थोड़ा ज़्यादा compounds बनाता है as compared to group 1. Obviously because its valency being 2 and having a bit 2 oxidation states of +1 and +2 being more stable. That way. But magnesium and beryllium they do not react with water because वो पहले ही अपने ऊपर एक ऑक्साइड लेयर बना लेते हैं, तो वो पानी से रिएक्ट नहीं करेंगे. बाकी अदर एलिमेंट्स दे रिएक्ट विथ वाटर टू गिव यू करस्पॉन्डिंग हाइड्रोक्साइड्स. इस तरीके से दे फॉर्म द करस्पॉन्डिंग हाइड्रोक्साइड्स. ये देखो, calcium is forming calcium hydroxide once dissolved in water. तो बेरिलियम को छोड़ दें हम, तो बाकी सब एलिमेंट्स दे आर फॉर्मिंग when these oxides are dissolved in water they form corresponding hydroxides. Obviously they are alkaline, that's why we call them as alkaline earth metals. Size देखें हाइड्रोक्साइड्स का, it increases down the group, and as the size increases their solubility increases, thermal stability increases, and basic character also increases down the group. If I talk about beryllium hydroxide, it has this amphoteric nature. It's not basic, it's amphoteric. It behaves both as acidic as well as basic. Again, because of its anomalous behavior, its smaller size, its ability to form covalent bonds, because of its smaller size, that way. एक तो it also does not accept electron pairs with hydroxyl ions. ये देखो, so it is acting as both. Now the question is, why do these hydroxides become more stable down the group? Now these cations are increasing in radius as we move down the group. The radius is increasing. As this distance is increasing, the ease to remove electron is increasing. So E is increasing, so IP is reducing. Ionization potential is decreasing. And that is why they easily get dissolved, easily react, and they are soluble in water. Simple as that. So the beryllium or magnesium, again I told you, they will not react because they form oxide layer. All of them, they react with oxygen to give you corresponding metal oxides. ठीक है, calcium forms calcium oxide, magnesium oxide, solution oxide, and so on. Magnesium and beryllium, they will react very vigorously with air with a release of a high amount of energy to form the corresponding oxide as well as nitride because of two क्या बोलते हैं electrons in the outermost shell. All of them, they react with air to form their corresponding oxides and nitrides. beryllium is essentially covalent in character, obviously because anomalous behavior, amphoteric है, can act as both acid and bases. This is because of the diagonal relationship with aluminium. Aluminium oxide भी ऐसा ही होता है बेटा, ये भी हमने डिस्कस किया था. Most of them are ionic substances, obviously leaving beryllium for obvious reasons. अच्छा, बेरिलियम को अगर छोड़ दें तो दे आर बेसिक एनहाइड्राइड्स, माने इनको पानी में डिसॉल्व किया तो ये हाइड्रोक्साइड बनाएंगे जो बेसिक होते हैं. दैट्स व्हाई अल्कलाइन मेटल्स. बच्चों हो कि चले गए? ठीक है. दे रिएक्ट विद हैलोजेंस एट हाई टेम्परेचर्स टू गिव यू करस्पॉन्डिंग हलाइड्स. वहां जहां पे ग्रुप वन एलिमेंट्स तुरंत रिएक्ट होते थे, they are here reacting at a higher temperature, obviously because higher IP required to remove those two electrons, so we will require more energy over here. These reasons were discussed. So again, these salts are soluble in water, and ammonia के साथ they are forming complex. Oh, that is so nice. सब लोग हैं. Very good. Thank you for bearing me. So, halide salts of alkaline earth metals, they are essentially ionic in character, obviously with exception of beryllium, which is covalent in character. Jai Shri Ram. Yeah, man, yeah, thanks. Here light salts, they are beryllium chloride actually has a chain structure. However, other chlorides की अगर मैं बात करूं, so they are not showing this chain structure, and it forms a dimer. मतलब two molecules associated with each other is exactly similar like aluminium. तो इसीलिए इसका diagonal relationship with aluminium बहुत जमता है. Hydrated salts बनाता है associated with water molecules, but when heated they lose this water crystallization and forms anhydrous salts. So hydrate salt का anhydrous होता है, जब आप इसको हीट करेंगे इसका water evaporate हो जाता है. This way they get dehydrated and they get the anhydrous powdery version of the salt. Simple as that. I don't know why it's showing nationalist movement of India. It's but weird. The fluoride salts are less soluble as compared to chloride salts because of high lattice enthalpy or high energy associated in breaking those bonds over there. With hydrogen, they form the corresponding hydrides, calcium hydride, magnesium hydride, and all. Simple hydrides बनाता है. ये देखिए, beryllium hydride is only formed when beryllium chloride and lithium aluminium hydrate is reacted. Otherwise, other elements simply react with HCl and they release hydrogen gas as a product. If we look, they have large negative reduction potential, so they act as good reducing agents. Okay, and that is why the electrons will easily lose electrons. Yeah, maybe. So same, they are good reducing agents. So liquid ammonia में the group 2 elements again will dissolve and form deep blue solution because of the electronated ammonia. Again ये मैंने आपको clearly समझाया था बोर्ड पे कि exactly क्या हो रहा है, कैसे हो रहा है. मोटा मोटी this again we have done important compounds of group 2 elements की अगर मैं बात करूं, carbonates, they are water soluble, metal carbonates and all, they can simply be produced by reacting with their corresponding chlorides. ये देखो, these carbonates on heating they break down and they release carbon dioxide. कैल्शियम कार्बोनेट को देखो, कैल्शियम ऑक्साइड, और ये देता है कार्बन डाइऑक्साइड. The tendency to form carbonate increases down the group, and it increases as we move down the group over here. All these sulfates and all, they are unstable and are water soluble. They have to be stored properly. Again, because they are having high hydration enthalpies, but इतना मगजमारी में अपने को नहीं पड़ना है. Look at this. This is how the metals they actually look like. Again, they are used in alloys and X-rays. ये सिर्फ simple uses है जो हमने already देखे हुए हैं. Plain parts, antacids, toothpastes, and this, that. Beryllium का anomalous behavior we talked about and all. Charge to radius ratio or simply ionic size of beryllium and aluminium, they form oxides. Both of them are soluble in organic solvents. They form dimer molecules. This तरीके से AlCl3 and BlCl3, two molecules exist together that way. That is called as a dimer. This way. So we had discussed. Then these, I had shown you this video previously also about the what do we say, the important compounds and the biological importance. बहुत recently आपको दिखाया था ये. तो एक overview की अगर मैं तेरा बात करूं तो एक there was a very quick revision of group 1 and 2 elements. What I would expect from you is to just go through the textbook and read it once before we start solving the necessary. No, Shreya, it's not buffering. Before we start the necessary, क्या बोलते हैं, entrance level questions or MCQs related to this chapter. ठीक है? That way, just read through it. That way. So I hope this should be good enough. Okay. um, Go to the chapter. We have almost done this chapter twice now on the board through the video. I don't think so you will be having any difficulty. If any, obviously I'm always reachable. अभी दुनिया खत्म नहीं हुई है. We will what do we say, discuss various MCQs related to this chapter in the next lecture which we will take ahead. ठीक है. So I guess you can have a good weekend ahead or prepare for your tests or whatever you think is good. And I may relax a bit now. A 1 hour lecture is good enough for today, if you agree. Your help in एक minute. Specified. Okay. जेगीज वीक कभी एंड ही नहीं होते. वीकेंड नाम की कोई चीज नहीं. हाँ, तो अगर जिंदगी में कुछ बड़ा हासिल करना है तो मेहनत करनी पड़ेगी. हम स्टूडेंट्स से हमने भी किया था, तो रो मत बेटा. ठीक है ना. मुझे भी वीकेंड नहीं होता. मुझे कल भी लेक्चर्स लेने हैं. मैंने आज भी लेक्चर्स लिए. सो रोना नहीं है बिल्कुल. ठीक है ना बच्चे. जिंदगी का नाम, दिस इज व्हाट इज लाइफ एंड लाइफ विल गो ऑन. So stop cribbing and start working hard if you want to achieve your goals. Life is never going to be better ahead also. You will have to work hard and stop looking up for holidays and start looking up for more time. So stop cribbing and start working hard if you want to achieve your dreams. If you have money in your account, you can take out time and have fun at any point of time. So if you want that, you have to work hard. सिंपल एज दैट. तो ठीक है ना. अभी लेक्चर है मेरा. लेक्चर जल्दी हो गया. थोड़ा रिलैक्स कर लो. नहीं, पर हमने तो रोना है. हमको छिट्टी नहीं है, हमको ये नहीं है. अरे भाई, तुम स्टूडेंट फेज में हो. घर से बैठ के क्या बोलते पढ़ाई कर रहे हो. हमारे इसमें तो ये भी नहीं था. हमारे टाइम पे तो क्लास, कॉलेज, दिस दैट, अगड़म मगड़म बहुत पंचायत था. एंड उससे पहले तो जय श्री राम बोलते रहते हो. वो लोग के टाइम तो आश्रम में भेजते थे. उनकी लाइफ कैसी थी वो सब नहीं देखना है. बस पंचायत करनी है तुम लोग को. पढ़ाई करो सबके सब. चलो बाय. टेक केयर. Yes, that was weekend motivation. बाय गाइस यार, जाओ यार, जीने दो, जियो और जीने दो थोड़ा सा। बाय बोलो यार फटाक से, ताकि मैं लिंक कैंसिल कर सकूं। तो ये इतना पीछे चल रहा है। हाँ तो पैंडेमिक था ना, नहीं था तो क्या हुआ, दिमाग खराब। पैंडेमिक में भी तुम कितनी तुम लोग कितना घूम रहे हो, फिर रहे हो, मजे कर रहे हो, सब मेरे को पता चलता है। तो जस्ट डोंट गिव मी द एक्सक्यूज ऑफ पैंडेमिक। तुम में से किसी को कुछ हुआ नहीं है तो ज़्यादा उड़ो मत, ठीक है ना। पैंडेमिक नया वर्ड सीख लिया है, पैंडेमिक। आज से पहले कभी पैंडेमिक पता भी नहीं था। अंग्रेज अंग्रेज। चलो बाय बाय बाय, गेट लॉस्ट, लेट्स टॉक ऑफलाइन नाउ।